concept of degrees of freedom, abbreviated to DOF, is very important for tracking technologies as this concept describes the limits of physical movement. For virtual reality, there are two types of devices: the ones that support 3 degrees of freedom and the ones that support 6 degrees of freedom. 3 degrees of freedom devices do not track movement. They track just head rotation in 3 axes. They track the head's pitch, yaw, and roll. If you need to move in virtual reality, you need to use controllers for relocation. 6 degrees of freedom devices allow free movement. Such devices track the position of the headset in space in addition to pitch, yaw, and roll. Sometimes you'll find another term that denotes the possibility of free movement: room scale. This is because 6 degrees of freedom devices allow the player to perform tasks using natural movements, such as walking across a room and picking up a key from a table. A natural movement allows people to feel well in virtual environment, in contrast to many other locomotion methods. There are different methods that allow tracking virtual reality devices: outside-in tracking and inside-out tracking. Let's talk a bit about IMUs, which play an important role in tracking technologies. IMU, or Inertial Measurement Unit, is a technology that measures specific force, angular rate, and sometimes orientation. IMUs use accelerometers, gyroscopes, and sometimes magnetometers for that purpose. VR devices use IMUs extensively for tracking in addition to other methods for better accuracy. These devices also help to proceed with tracking when other signals are lost for short periods of time. Remember, I already mentioned outside-in and inside-out tracking. Let's talk about outside-in tracking. It uses cameras or other sensors that are not attached to the object being tracked. The cameras normally face the object being tracked, and the object is tracked as long as it remains in a field of view of all cameras, or one camera. Infrared light cameras are often used for that purpose. Such technologies, for example the Lighthouse system, are very accurate but have a limited range. For example, the HTC Vive system can track an area of 5 square meters without additional sensors. Also, such systems require calibration. It takes around 5 minutes to calibrate the HTC Vive system. In contrast to outside-in systems, inside-out systems use cameras or sensors mounted on the object being tracked. Such systems track the environment and calculate the local displacement. Visible light is commonly used for such kind of tracking. Theoretically, the tracked area may be unlimited, but most devices require to define it for safety reasons. As such systems track the environment, they do not work well in dynamically changing environments. Both tracking methods provide an accurate way to track virtual reality devices. Still, there are environmental conditions that make tracking difficult. For example, tracking almost always uses an optical signal which can be disrupted by objects obstructing the sensors. Systems that use infrared light are sensitive to sunlight and other infrared light sources. If you are planning to use virtual reality outside, tracking may fail on a sunny day. Tracking may also fail if other virtual reality systems are located nearby, which is the case during exhibitions. Also, systems that use visible light may fail in poorly lit environments.